I'm really excited to be here this afternoon again to present what we've managed to do so far with Moduloop, with the help also with African Ender towards this project that we have of interoperability. As I introduced earlier, the project of RNDPS, which is basically Rwanda National Digital Payment System, is about interoperability. So we started 3 years ago, and obviously we had a certain technology that we acquired to see how to move forward with the use cases that we had. But down the road, we realized that if we really want to tackle certain key objectives, such as the inclusivity, making sure that the pricing is really accessible and affordable to everyone, and ensure that there's a higher uptake and velocity, we needed maybe to look into also how to minimize both the cost of operations and have a robust technology. So with the partnership that we had, we embarked on this project. And the objective was first to look at how we could integrate without disrupting what is already existing, which is the initial integration that we've done with all the participants. So today, I would like to invite the Wired team, Alain and team, to do a bit of demo to show you how far we are. It's really exciting, and we look forward to more use cases and do amazing things. Thank you.
Thank you very much, Blaise, for the kind introduction. So my name is Alain Kajangwe. I'm the founder and CEO of Wired. We're a software company based in Kigali, Rwanda. I've been to 3, maybe 4 convening now. We were fortunate enough to be among the first to do the accelerator program of the Moduloop platform. So that was very helpful towards getting us started to what we are showing today. So for a brief background of the project, like Blaise was saying, this comes as a version 2 of the RNDPS project. The version 1 was running on for the use case of P2P, and the current implementation use case was to be on merchant payments running on Moduloop. So like Blaise was highlighting, the whole project resolved around not disrupting. At least one of the main components was to not disrupt what was already working, meaning the DFSPs that were already connected to the first platform should not feel like they need to adopt a new set of APIs, right? So we'll show what we managed to do. So the first thing that we did was deploy the Moduloop platform on premise. So now the Moduloop platform has been deployed on Rswitch servers, and we have done a number of customizations towards making sure that the DFSPs that were already connected remain using the same set of APIs. In Rwanda, those APIs basically are the ISO 222. We like to call it the Rswitch flavor because of the security layer that was added to that standard. So what we did essentially, and we'll show this, I think we have a presentation, so maybe we can actually project it, and then we'll quickly go through the presentation. And then after the presentation, we'll show a quick demo of what we've actually managed to do. Where we stand today, we have done all the integration tests simulated, where 2 DFSPs in Rwanda are using the ISO 222 Rswitch flavored to communicate with each other via the module loop switch. So if we have the presentation that we shared earlier, maybe we can project it, and then I'll ask Max to come first and then talk about the on-premise deployment, and then we'll briefly talk about the customizations that we did around the module loop components. That's basically the components that make up the module loop switch, and then we'll end with a quick demo of what we've done.
Good afternoon, everyone. So let me start introducing myself. I am Maximilien Bingabo, a software engineer at Wiredin, based in Kigali, Rwanda. So I had a chance to work on the module loop deployment on-premise. So that's what we'll be telling you the experience we had. So the infrastructure at Rswitch is made of a bare metal, a server with 3 compute nodes, and the hypercore is installed above the electron, the bare metal hardware, and the hypercore is serving as the hypervisor across all the compute nodes. So on top of hypervisor, we managed to create virtual machines or VMs that made up a cluster. So we are using Kubernetes to manage to manage the application, the containers. So, and all VMs are running Rswitch, which is an immutable operating system. We choose Rswitch because of its immutability. So immutability means whatever change is made on the file system, after a reboot, they all get erased. It is done for security purpose and reliability. So, for example, if an attacker attacks the system, so the attack won't be there forever. So after a reboot, so every changes get reverted. And also we choose Rswitch for its maintainability. So whenever you want to upgrade the system, it's atomic. So you upgrade everything and the system is reliable. So I'm also going to talk about the module loop ham deployment, how we deployed module loop using ham tool or ham charts. So we deployed it using the module loop ham charts, but with custom values. Or we choose a custom configuration because we wanted to achieve, as per our design, each service has its own provisioned VM based on its specifications and also the route it will handle. So we customized the values to choose or to have each service to its own virtual machine, and also to deploy from our custom repositories, as we had some customization, so we want to deploy those changes on the server as well. So I have some diagrams here of the infrastructure. So whenever they put a presentation, I'll show you how the infrastructure is set up and also the next steps. As Aaron said, so the module is deployed and it's working on Rswitch servers, but it's still in progress. So we have some next steps to carry on. The first one is to prepare the module ham chart, which are production ready. So for example, we used the example backend ham chart. So here is the infrastructure diagram I was talking about. So we have HCI. HCI is a bare metal hyperconverged infrastructure. So it's a very performant hardware. And on top of the HCI, the bare metal, we have hypercore, which act as a hypervisor. And on top of hypercore, we have different virtual machines, or we have different nodes. So we have also a Pixie server. It's a virtual machine which we use to serve the operating system, the immutable operating system, to other VMs. And the VMs, as I said, are running Kairos operating system for its immutability. And on top of the virtual machines, we have the modular services in form of containers, which are running using Kubernetes. So here is actually the infrastructure we do have at Rswitch. Next is the modular PAM deployment. As I said, we use the custom configuration to deploy from our repositories and also to provision a service to a certain computing node or computing virtual machine. So next steps, so we are going to prepare some production ready Helm charts. For example, on the backend, we used to deploy backend, we used the example Helm chart, which combine everything, but we want to separate each service, each backend service to monitor the deployment and also to make sure the deployment is successful on its own. And also, we want to set up a continuous integration and delivery so that we automate the whole process, the whole deployment from the development, from merging the code to the servers. That's what we are currently working on in the next couple of months, is to make ready that our deployment processes are very well streamlined and automated. So let me invite my friend Bonaparte to talk about customization we made during the past month so that he can go through those customization.
Good afternoon, everyone. As my colleague said, my name is Bonaparte Tuze. I'm also part of DIN and most importantly, part of the team that is working on making this milestone in merchant payments. For now, more use cases later, but this merchant payment is success. So I'm currently serving as a director of engineering at DIN, and I'm going to talk about some customizations that we made so far to make the current version of Mojaroop as it is, to make it work at least for an end-to-end payment, as Alain said that we have that working now. Yeah, so the first step that we had to take is, because currently DFSPs in Rwanda do not, or at least are not accustomed to integrating to the switch through Mojaroop APIs. So that means there has to be kind of a middleman that translate whatever they're used to right now to what or to how Mojaroop does things as of now. So we have what we call an Rswitch connector. It's basically like a service that sits in the middle between Mojaroop services and DFSPs, takes in the ISO 222 some messages that they're used to sending to the switch. And basically what we do is we take that one. Of course, there is some validations, whether that message is valid, some digital signatures associated with it. And when it's valid, the connector basically does the job of now translate everything to the language that Mojaroop services understands. So with that, that means that we have at least DFSPs able to connect to the switch. So the next iteration, obviously, is to actually be able to register some merchants. So for that, we made use of an already existing awesome modular merchant acquiring system that we took and tried to think about, at least in the shortest time as possible, how can we make this work in the Rwandan use case. So we have merchant registration. Currently, the only difference that we noticed when we first looked at it is that our DFSPs are used to registering merchants through back APIs as opposed to giving them a user interface that they can use to register merchants. So we had to develop a new an API. It's really just like exposing services because most of the modules to support that were there. So we developed new APIs that allowed DFSPs to register their own merchants that they already have in their databases. And of course, as we talked about, them being used to ISO 222 messages. So the whole process has to go through the switch, but also the merchant acquiring services have to know how to talk to the Rswitch connector to be able to register merchants. So basically, as we see on the diagram at the bottom there, we have DFSP sending a merchant registration request to the Rswitch connector, and then the Rswitch connector goes to merchant acquiring backend directly to register merchants. And worth noting that there is also a difference here that both the merchant acquiring backend and the Oracle do not have, in this use case, do not have the power or at least the responsibility to generate merchant aliases or TID codes, as we call them. So everything has to come from the DFSPs, and it's the only single source of truth. So obviously, after we register merchants, the next step is how do we do the lookup of merchants? There is one major change here that we had to, or not really a change, but a slight deviation from how Modular was currently doing things, is that when you actually go to look for merchants in the Oracle, the expectation is that the switch should not go to the DFSP to look for merchant details or in format terms account details. Everything in this case has to be inside the switch, and it has to know everything basically. So the lookup had to be handled by both the account lookup service and the Oracle without making any API call to the DFSPs. So for this, we had to implement a new set of APIs on both the Oracle and the merchant acquiring backend. So merchant acquiring backend is just some APIs to interact with the merchant database. So you had to add new APIs that are able to return full information about the merchant. That includes the contact names, the business registration IDs, basically everything that a DFSP that is trying to do a lookup on the merchant will need. And then when we get that, we actually don't need to go to the DFSP to get anything because we have everything in a place. So basically with that, how the merchant lookup works is, as we talked about, everything that comes to the switch goes through the Rswitch connector, and then from there we use our already existing SDK schema adapter that is already a Modular API, a Modular service, and then it goes to the account lookup service, but modified to not contact the FSPs for merchant details. So one more customizations that I had to make is on the quoting process, because currently in Rwanda, at least as of now, there is no concept of dynamic quoting. So which means our DFSPs do not expect that you go to them to ask for quotes on a transfer, or in this case, a payment. So now we needed to change the coating service to account for that. So the approach we took here is that based on, like we're looking for quick wins here. If we were to eliminate the coating service as of the entire service to start with, that will make everything not functional, and then future implementations become harder that way, because basically you don't have a functioning switch that you can iterate against. So what we did is we actually took the SDK scheme adapter. We introduced new configuration values to tell it basically on this particular deployment type. What we expect is static codes, and you should not go. You should not be instructing the Rswitch connector to ask for codes from the FSP. So basically, that dynamic codes configuration value, we have it enabled on all our deployments, and that tells the scheme adapter to basically, whenever there is a request for codes, just say that the commission fees is 0, and then everything works as it used to work. On the central ledger, we had very little to add here, because basically it's when it gets to the central ledger, everything is just a transfer. What we did is a small change here, because we wanted to, or at least the hub operators had a request to be able to see transactions as they come in live. As it sounds, this is somehow it requires a bit of attention in terms of the architecture of designing this. But for now, we have new APIs that we added on the central ledger to basically go in the transactions databases and query for transactions, whether successful or aborted. But of course, come with the history, how the transfer basically moved from reserved up to committed, and all the way up to settled. So we added the new APIs here. The drawback, or at least what we anticipate at this point, is that might be costly, especially as we onboard multiple DFSPs. So that is that remains kind of a to-do on our table to look for a more optimized implementation of doing that without putting a lot of stress on database of central ledger, as it's the central database for everything or most of the things that the switch does. So basically, with everything that I've talked about, we were able to achieve end-to-end. But also we have some things that we logged that we've already identified so far that could be a problem in the near future. One of them is the nature of scheme adapter APIs being synchronous. I think it made sense as it stands now, because they were supposed to go directly to the DFSPs, and probably most of them will not be ready to implement asynchronous APIs. But in our case, they are, because they're already using them. So we want to change the scheme adapter APIs as soon as possible to work asynchronously. And of course, one of the ways to do that is we either introduce some Kafka topics, or any way we can come up to use PubSub model to have the Rswitch connector, which already communicates with DFSPs asynchronously, to have it also communicate with scheme adapters asynchronously. And we make sure basically that we try to reduce the point of failures as much as we can. So yeah, so we're planning to achieve this as soon as possible. But of course, it's not only this. We will be doing many things, and as always, anything we do, we try to not change, but rather have the services, the modular services, adapt to what we need, so that it can be later also contributed to the community without having to change what everyone already has. So I would like to invite colleague Alan to talk about the ISO 222. Thank you very much.
So as we are running out of time, so I'm just going to go through my remaining slides a little bit faster so that we can show you the demo. So our apologies for taking long. So we'll just go through. So this is just a general overview of of the architectural diagram of what we're doing with Rswitch. Okay, so slides are gone. Yeah. Okay, so since the rest of my presentation basically was to just go through that diagram that you just saw there, and then just the process flows that actually Bonaparte already talked about. So I'll just give him a few minutes to set up for the demo, and then that'll be it from us. So again, apologies for taking a little bit of time, Simeon. I'm sure we'll have to answer to you at some point. So the demo we're going to show is, so what we were planning on doing all along was to make sure that we can do an end-to-end transaction transfer between a DFSP on one end, the standard DFSP, and then on the other end, the DFSPs that will be receiving the money. So we managed to achieve this, and the solution is fully deployed on Rswitch servers. So we were hoping to show this via connecting to the VPN. Unfortunately, we're going to show the demo from our local host because of internet issues, and then also because once we are on the VPN, we lose internet pretty much. So, but the solution is already deployed, and we are hoping that at some point we'll be able to actually start testing end-to-end with actual DFSPs pretty soon. And yeah, and then from there, we'll start maybe looking at other use cases. But for now, the use case that we are most concentrating on is definitely the P2B or merchant payments. Maybe as he set up, maybe I can just go through this real quickly. So as you can see on one end, on the left side, you have the payer, the FSP, that initiates a credit transfer. For those of you who are familiar with the ISO 222, you'll recognize the message types here. So this is the transaction flow for the credit transfer. So the DFSP send a PAX 008 to the Rswitch connector, which then translates this PAX 008 into a module loop SDK API, and then communicates with the scheme adapter, and then the rest happens inside the module loop hub. And then eventually, once this transaction has been committed, it sends a request again to the connector so that the connector can make a PAX 008 credit transfer request to the payee DFSP. And then the payee DFSP will respond asynchronously to the connector with its transaction status in the form of PAX 002 ISO 222 message. Right, so all this is already implemented and actually tested. So maybe, yeah, and then maybe what we're going to be doing next is, like I said, end-to-end tests with DFSPs. And then we're going to start working on some of the back office, very important back office modules that were talked about earlier today. An auto reconciliation and dispute management module. Apologies. And then also we'll be integrating with the fraud management system. Actually, the fraud management system that we're planning on using here is already an open source project that is already supported on the module loop. That's the Ikuta FRMS. So we'll be working with Greg and Yeah, and we've actually already had a couple of discussions with Greg, and that's the system that most likely we're going to adopt for this particular module. And then after that, we'll be looking at the additional use cases.
I'm going to quickly show part of what you had planned to show, at least what we can see visually. So this is the basically for the switch. This is the hub operator user interface that I was talking about. So this allows operators sitting at Rswitch to basically operate the hub. So this is it's a work in progress. Very little has been added now, and more to be added later. So basically, what we do is, if you come here, you are able to, for example, add some currency accounts on the hub. Like for example, you add reconciliation and settlement accounts. Then, if we have, for example, a new financial service provider that we want to onboard, we basically come here and so this is blocking my view. Okay, for now. So and we are able to add the new financial service provider with basically the name. Here we had the challenge because in Rwanda people are used to DFSP codes, not the name. So there is the digits and what they are actually called, but you add the name and then you assign some initial currency together with a debit cap on that financial service provider. So this is what you see in terms of details for a financial service provider. We're able to add callbacks. Again, because of technical difficulties, this is a Morocco environment, but everything points to the scheme adapter that handles the callbacks for this particular FSP that we onboarded here. And then the same way we are able to add more currencies and be able to deposit some settlement funds to that DFSP. Of course, in the actual world, this does not come from the hub operator using the UI to add those. It comes from the central bank, but this is just to allow the testing for the current phase. And we talked about the merchant oracle that we had connected to the switch. So this is basically the endpoint that goes to the oracle so that the account lookup service, whenever a particular DFSP is interested in a merchant code that they can resolve locally, they just go to the oracle and they're able to get results for you. So on transactions, this is like a list of transactions that are going through the switch. It shows, so on this case, it's a wallet, for example, an MTN wallet that is trying to make a payment to a merchant code that is sitting at Airtel. So you say what is the original DFSP, what's the destination DFSP, what is actually the amount and the currency that was being used in that transfer, and then we are able to show the final status. And again, all these are waiting to be settled later. And whenever there is an interruption in the middle, let's say, for example, you try to send an amount that exceeds the settlement limit, then that doesn't go through and that is marked as aborted. So basically everything that I'm showing here is from a switch, an exact replica of what we have on the server, but running on my local machine. I think that shows how efficient the modular as a switch itself is, the fact that it can run on my local machine. So when as of now, to just to see the list of merchants that we have, this is a merchant acquiring admin interface that was already there. We had to tweak a few things and to just make it working seamlessly, but the biggest percentage is what we already provided with. But basically, we are able to register merchants through the back API that I talked about in the presentation, and then these are what is used in the lookup. So to end, maybe I would like to look at this one. So this is basically a payment simulator that we are starting to basically kind of simulate for people who don't want to go through the pain of using Postman or any other API client to test the switch. So it's in a way, it's an exact copy of what testing toolkit does for us. But the limitation we have right now is that testing toolkit does not support ISO 222 as of the current version, which of course we intend of fixing, but this is a quick win for us. So basically when you put a merchant code here, again, testing environment, don't mind the sequence. Basically does a lookup through the connector, then scheme adapter, and then all that. And then it returns the name of the merchant that you're trying to make a payment to. And let's say I want to pay 250, 2,500. And then I do send. So basically it shows that. So basically this on the right side here, we have a merchant phone that is in that small office of Wired in Academy, and they are able to see that Richard has just sent 2,500 Rwandan francs to them. Thank you very much.